Hello, my name is Igor Goryainov. I am first year master degree student at BMSTU, and the topic of my presentation is real-time collision avoidance for redundant manipulators. So, I have divided my presentation into several parts, and you can see the plan on this slide. So, first, let's understand what path planning is and how it's different from motion planning. Path planning is about creating route from starting point to end point, while motion planning gets into more detailed planning involving many time-based parameters. So here you can see the difference between global and local path. In the first image, path is direct from start to finish. In the second image, route considers obstacle encountered along the way. This article suggests path planning architecture, and it includes global planner working with static map data, and followed by local planner considered sensor data, and map updates based on sensor input. So, um, since this work focuses on manipulate robots, and it's important to define state space. So, with robot having 6 degrees of freedom, planning path involves considering each freedom degree. And the article proposes using RRT algorithm. Uh, so it's like rapidly exploring random trees. And its main idea is to create map of possible movements considering collision spaces. So let's say we have configuration space C and initial position Q0. The first step of algorithm is to randomly select a point within the configuration space. Next, on the created map G, how we call it, we find the closest point to generated one. When a vector is created between closest and random points. This vector is divided into several intermediate points and where collisions checks occur. So, if there are no collisions, we simply add a new point Q to our map that meets our conditions. So, however, if there is a collision, we select furthest intermediate point without collisions. Uh, this explains core principle of RRT algorithm, and we repeat these actions many times, creating a map. So, or more precisely, it's calling a graph. So, with points where we can move without collisions. When we find path in this graph from starting point Q start to Q finish by searching the graph. In the video, you will see how this algorithm works in real time. So, thank you much for your attention, and I will be happy to answer your questions.